Chapter 6: Anatomy of Alimentary Canal and Food Digestion. In the mouth, the food begins, chewed and mixed with saliva's winds, down the esophagus, smooth and tight, to the stomach's acid, burning bright. The small intestine, where nutrients are seized, absorbed by villi with care and ease. The liver and pancreas, partners in play, aid digestion day by day. In the large intestine, water's retained, waste is formed, the cycles sustained. A dance of organs working as one, the journey of digestion never done. What is the measurement of food we eat? Before determining this, let us study the anatomy and physiology of the digestive tract. The alimentary canal, which starts from the mouth and extends to the anus, is a hollow tract that averages about 9 meters, 30 feet in length. This canal consists of various parts including the mouth, tongue, teeth, salivary glands, pharynx, throat, esophagus, stomach, small intestine, large intestine, appendix, liver, pancreas, gallbladder, rectum, and anus. By studying these components, we can better comprehend the process of digestion and its relation to the amount of food we eat. When food enters the oral cavity, the process of digestion begins. The teeth and tongue play a crucial role in masticating the food. The teeth grind the food into a mixture, while the tongue, which houses thousands of taste buds, helps identify the various tastes such as spicy, sweet, sour, bitter, pungent, astringent, and salty. However, the consumption of tobacco and tobacco-containing products can harm these taste buds, leading to a loss of taste perception. During the mastication process, the salivary glands are activated and secrete saliva into the oral cavity. These glands, located below the tongue and mandible, produce saliva that consists of water, minerals, ptyalin, mucus, protein, lysozyme, and proteolytic enzymes. On average, the secretion rate of saliva is approximately 5 ml per minute when maximum stimulated, amounting to 800 to 1500 ml over a 24-hour period. Saliva plays a vital role in lubricating the food, facilitating swallowing, and initiating the breakdown of carbohydrates through the action of enzymes like ptyalin. Saliva performs various important functions in the oral cavity and during the process of digestion. Number 1. Moistening the mouth. Saliva keeps the mouth cavity moist, ensuring comfortable movement of food and aiding in speech. Number 2. Thirst regulation. When the body requires hydration, the sensation of thirst is triggered by the presence of saliva. Number 3. Taste perception. Saliva helps in the perception of taste by dissolving food particles and carrying them to taste buds on the tongue, allowing us to experience different flavors. Number 4. oral hygiene. Saliva plays a role in maintaining oral hygiene by keeping the mouth clean and fresh, washing away food particles, and preventing the buildup of bacteria and plaque. Number 5. Antimicrobial action. Saliva contains antimicrobial components that help kill bacteria and protect the oral cavity from infections. Number 6. Digestion of starchy food. Saliva contains the enzyme amylase, ptyalin, that starts breaking down starches in the food, converting them into simpler sugars. This initial digestion process gives a slightly sweet taste to the food. Number 7. Digestive role. Saliva aids in the process of digestion by moistening the food, making it easier to swallow and facilitating its movement through the digestive tract. After being mixed with saliva, the masticated food bolus is propelled by the tongue into the pharynx and then enters the esophagus for further digestion and transportation to the stomach. Esophagus. The esophagus, which begins in the throat region and opens into the stomach, has an average length of 25 centimeters. The food bolus is transported to the stomach through the peristaltic movements of the esophagus. The inner lining of the esophagus, carrying morsel from mouth to stomach, is different from the lining of the stomach. The stomach is protected from its acidic environment by its thick mucosal epithelial lining overlaid with mucus secretions to prevent self-digestion, which happens in chronic gastritis due to unhealthy eating habits. But esophagus is just a carrying tube that does not have this inherent protection. Anything that causes the backflow of food and gastric juices to the esophagus literally causes the burning of esophageal mucosa, leading to a condition called gastroesophageal reflux disease, GERD. It includes heartburn, retching, pain in the upper quadrant of the abdomen, nausea, vomiting, headache, and dizziness. Sometimes symptoms mimic an acute heart attack. Frequently, these people overlook these symptoms and one day they have a real heart attack and mistake it for gastritis. Eating sattvic food with mindful method of charvan will prevent such diseases. Stomach. The stomach is situated beneath the ribs on the left side of the abdomen. It has a J shape and can hold approximately 1.5 liters of food. The inner lining of the stomach contains gastric glands that secrete hydrochloric acid and gastric juices. These glands produce about 0.5 to 1.5 liters of acid and gastric juices within a 24-hour period. Upon food entering the stomach, the gastric juices and acid undergo thorough mixing through gastric contractions called titanic contractions, which occur every 2 to 3 minutes. These contractions are also stimulated during hunger or when a person consumes a smaller meal. The hormone gastrin plays a role in controlling these contractions. While half of the digestion takes place in the mouth cavity, The remaining portion of the food undergoes the action of gastric juices and enzymes in the stomach before being passed on to the small intestine for further digestion and absorption. Functions of stomach. Number 1. Temporarily storing food material. Number 2. Mixing gastric juices and acid with food. Number 3. Eliminating bacteria through the action of acid. Number 4. Churning the food. Number 5. Initiating digestion of food. Number 6. Producing precursors for the absorption of vitamin B. Number 7. Absorbing water, minerals, sugar, and medicines. The stomach is divided into 4 compartments, and ideally, 3 of these compartments should be filled with food, water, and air, while the 4th compartment should remain empty. Small intestine. The small intestine, positioned between the stomach and large intestine, has an average length of 600 centimeters, 20 feet. It maintains an alkaline pH of 9. The small intestine is further divided into 3 parts: the duodenum, the jejunum, and ileum. Both the pancreatic duct and bile duct open into the duodenum. Within the small intestine, food undergoes churning, a process that typically occurs within 2 to 3 minutes. In instances of excessive food consumption, the jejunum releases the enzyme cholecystokinin, leading to a delayed emptying of the stomach. Functions of small intestine. Number 1. Transportation of food material through peristaltic movements which involve the contraction and relaxation of the intrinsic muscles in the intestinal wall. Number 2. Digestion and absorption of proteins, carbohydrates, and fats. Number 3. Absorption of calcium. Number 4. Protection against bacterial contamination through lymphatic secretion. Bile salts play a crucial role in preventing food putrefaction in the small intestine. Insufficient secretion of bile salts can lead to the rotting of food in the intestine, causing symptoms such as heat and burning sensation. It can also contribute to the development of stomatitis, colitis, and peptic ulcers. Prolonged accumulation of putrefied food material in the small intestine can lead to inflammation of its walls. This in turn triggers the overproduction of gastric acid, reflux of pancreatic enzymes and bile into the upper digestive tract. A vicious cycle of inflammation, acidity, and poor digestion persists until the pH is restored and harmful material is cleared. Duodenum. The efficiency of the duodenum relies on its ability to expand in volume. The duodenum serves as a reservoir for intestinal gas known as apana vayu. The primary function of this gas is the elimination of digested food feces from the body. When digested or partially digested food remains in the duodenum for an extended period, it leads to increased production of intestinal gas. This gas can become putrefied, resulting in foul-smelling flatulence expelled through the anus. When this gas, apanavayu, is expelled, the feces are not effectively eliminated, leading to constipation. Furthermore, the putrefied gas may move upward towards the stomach or upper gastrointestinal tract, causing symptoms resembling a heart attack. Excessive food consumption or inadequate chewing of food can also contribute to the production of apanavayu, which is associated with various diseases. Large intestine. The large intestine, also known as the colon, is composed of several parts including the cecum, ascending colon, transverse colon, descending colon, pelvic colon, rectum, and anal canal. It has a length of approximately 150 centimeters, 5 feet. The process of eliminating feces from the body occurs between 8 to 15 hours after the food reaches the large intestine. On average, about 1000 to 1500 ml of fecal matter is excreted within a 24-hour period. Functions of large intestine. Number 1. Absorption of water and electrolytes from digested food, leading to the formation of solid feces. Number 2. Storage and compaction of fecal matter before elimination. Number 3. Maintenance of a moist and lubricated environment within the colon through the secretion of mucus. Number 4. Synthesis and absorption of certain vitamins, particularly vitamin B and vitamin K, produced by beneficial bacteria in the colon. And number 5. Excretion of waste material in the form of feces through the rectum and anus. These functions play a vital role in the final stages of digestion, water balance regulation, and elimination of waste from the body. Appendix. The appendix is a small finger-shaped pouch located at the junction of the small and large intestines. It typically measures around 5 to 6 centimeters in length and has a blind end. While the exact function of the appendix is still a subject of debate, it is widely believed that the appendix does not play a significant role in the digestion of food. However, recent research suggests that the appendix may serve as a reservoir for beneficial gut bacteria and play a role in immune function, though its absence does not cause any significant health issues. Liver. The liver is one of the vital organs in our body alongside the brain, heart, and kidneys. If any of these organs malfunction, it can lead to serious health issues. The liver, weighing approximately 1.5 kg, is the largest gland in the body. It is situated on the right side below the ribs. Remarkably, the liver has the capacity to purify or detoxify around 800 to 1000 ml of blood per minute. It serves as the largest laboratory within our body, performing numerous essential functions. Functions of liver. The liver performs several crucial functions in the body, including Number 1. Conversion of glucose into glycogen, a storage form of carbohydrates which is facilitated by amino acids. Number 2. Production of bile salts with a daily output of 500 to 1000 ml, which aids in the digestion and absorption of fats. Number 3. Synthesis of water-soluble vitamins such as vitamin C and B complex vitamins, as well as fat-soluble vitamins such as vitamin A, vitamin D, vitamin E, and vitamin K. The liver deserves the position of a mother, or perhaps something even more generous. A mother is blessed with the capacity for reproduction and rejuvenation, and so is the liver. The liver is a unique organ capable of regeneration. Our bodies are remarkably specific about accepting foreign input. During organ transplants, even with matched blood groups and tissue specifications, 100% match is rare. Recipient patients require high doses of immunosuppressant drugs to prevent the rejection of the grafted organ. The liver is the secondary immune apparatus. It helps in filtering blood, clearing pathogens, and producing immune-related proteins like complement proteins that identify foreign tissues and trigger antibodies to reject it. Even a mother's body, which nurtures a baby in the womb, initially treats the fetus as foreign. Often, the baby and mother have different blood groups. After some weeks, the mother's circulation and immune system adapt. The same liver that rejects a donated organ from the same species, even from blood relatives, readily accepts food from diverse sources. Why don't we experience food allergies more frequently? It's due to the liver's generosity. Anything foreign to the body entering through routes other than the digestive tract is rejected by the liver. However, food, regardless of its origin, is welcomed when it arrives via the digestive system. The liver performs a remarkable transformation, removing all antigenicity, foreignness, and making it our own. It's akin to giving someone a rebirth, erasing all identifying tags and imbuing it with the qualities of our own body. Plants, vegetables, and fruits are converted into human flesh, muscle, bone, and blood. Let us explore the life cycle of RBCs, from bone marrow to bile. Blood, the purest, untouched, eternal, and sacred source of life, flows ceaselessly through the body, carrying the essence of existence from one moment to the next, from one life to another. The formation of red blood cells, RBCs, the very carriers of this sacred life force, is a symphony of contributions from multiple organs and nutrients. The intestine absorbs essential elements like iron and vitamin B12, the latter with the aid of intrinsic factor produced in the stomach. Meanwhile, the kidneys release erythropoietin, a hormone that stimulates the bone marrow, where ancestral stem cells awaken to give birth to new RBCs. These cells live a purposeful life of about 120 days, tirelessly delivering oxygen throughout the body. As they age, RBCs lose their flexibility and function. It is then that the spleen, often called the graveyard of RBCs, filters them out and breaks them down into heme and globin. The liver receives the heme, where iron is recycled and returned to the bloodstream for future use. The remaining heme is converted into biliverdin, then into bilirubin, a golden pigment that is stored in the gallbladder and later secreted into bile, aiding in digestion and waste elimination via the bile duct. Thus, the intestines, kidney, and liver orchestrate the birth of RBCs, while the spleen and liver gently guide them into renewal and release, completing a sacred cycle of life, service, and transformation. Gallbladder. The gallbladder is positioned behind the liver on its ventral side. Its primary role is to store bile salts, typically in quantities ranging from 30 to 450 ml. In addition to storage, the gallbladder aids in the absorption of water and facilitates the digestion of fats in the duodenum through the release of bile salts. Pancreas. The pancreas weighs approximately 55 to 65 grams and produce pancreatic juice with a pH ranging from 8 to 8.2. Insulin, a hormone, is produced by the beta cells of the pancreas. The secretion of insulin is influenced by the type and digestion of food consumed. One of the primary functions of the pancreas is to convert carbohydrates into starch and glycogen through the action of pancreatic amylase enzyme. Insulin plays a crucial role in regulating and maintaining the blood sugar level in the body. The alimentary canal is an intricate system where each organ works in harmony to digest food, absorb nutrients and water, and eliminate waste. The stomach secretes hydrochloric acid to break down food and activate enzymes. As the resulting chyme, a semi-liquid, partially digested food, enters the duodenum, the beginning of the small intestine, it mixes with alkaline bile from the liver and gallbladder and pancreatic juice from the pancreas. These secretions neutralize the acidic chyme and protect the intestinal lining, thus creating a slightly alkaline environment essential for enzyme activity and nutrient absorption. Among all organs, the liver stands out not only for its vital functions, but as the metaphorical mother of digestion, transforming what we consume into life itself. The journey of food from foreign matter to becoming a part of our very being is alchemy, and the liver is the master alchemist.